Hi, I'm Lars. Welcome back to the C# workshop. There's a lot more to talk about with classes and objects. This video will cover methods, inheritance, and dynamic polymorphism. If there's something specific that you need to learn more about, drop me a comment, send me an email, let me know, and I can get a video up for you. For right now, let's get to it. Just like the last video, this video will get you the information that is needed to learn C#. In order to get the most out of these videos, I recommend watching them in their intended order. There will be deep dive videos after the course. Class methods work just like the methods we talked about on day 8. The only real difference is the addition of access modifiers that I covered in the last video. For this, I'm going to use a simple hierarchy sample, and we're just going to create a class called shapes or shape. Like this, and inside of it we're just going to put a location. There's many ways that we could have done this, but I'm just going to say public X, Y, and then the height and width, and we're going to default those to 2. And I'm going to set these private, and I'll explain that in a minute, and that's a little bit to do with encapsulation. The other thing I'm going to drop in here is a method called draw. And it's just going to say performing drawing tasks. We're not getting into how do you draw lines on a screen. Hey, if you think there's too much information to remember, then like and subscribe to the channel. Then you'll have a URL that you can go back and look at anytime. And then over here in main, I'm gonna get rid of the console hello world. We're going to say shape is equal to new shape, and then just shape.draw. And that's how you would queue up a method inside of a class. And then the shape would be instantiated, and you would see height is 2, width is 2, X and Y. And that's pretty much it that you would see in the code. But over here, you would see performing drawing tasks, because once we got down to this draw, and I can show you this, you can step into that, and then you'll end up in the shape in that method. So not any different than what we talked about in the methods on day 8. Now the big thing is we're talking about methods, and when you start talking about inheritance and dynamic polymorphism and methods and classes and all this, they all get tied around each other. So what I'm going to do is, since we have shape here, I'm going to add some classes that I've already created. I just removed them from the product is what I did. So we're going to show all the files, and I'm just going to grab these guys, and I'm going to say include them in the project. And then we're going to get rid of that again. They're all going to inherit from shape. So we've got a triangle, a square, a rectangle, and a circle. And in order for them to do anything, if we're looking at the circle, we don't need any of this. All right, so we can get rid of that. And then in shape, we have this draw. So this is what dynamic polymorphism is we're going to override draw, and in order to do that, we need to make this a virtual. And that's what virtual means, is that you can override that method. And if I came over here and I said public, they have to have the same access modifier, and I type in override, it's going to show me, hey, your inherited class, your ancestor, has a method called draw and a couple other ones here, but we're only doing draw. And then what do we want to do here is, I'm just going to steal this line of code and come back to circle and say performing circle drawing tasks. I don't know what they would be, but then we would add this to the rest of the classes like rectangle and square and triangle. So we could do any of these. One thing that I did do over here on these is I gave it a console color to come up. This is a shape, so I can do a couple things here. I can say circle like this. Oops. I can say circle, and I can create a new circle and then call draw. And if we run this, you're going to say it says performing circle drawing tasks, just like you would think, because you're just inheriting from draw. If we create that shape, the shape will keep the height of 2 and width of 2 because it's inheriting that from shape. So all of these are available. Well, these are not, but these two are available to circle and triangle and rectangle and square. So again, if I come back here to program and I mouse over this, you will see height and width is set to 2, but they got a little lock next to them. That means I can't change them. I'm not really supposed to see them. They're just showing them to me. And X and Y are fairly able to be, anything can be done with them. And we'll finish off with the draw. Now, we actually do want access to these, but we didn't want to show them to the rest of the world. Okay, when it was just a shape. I wanted to be able to put a shape on the screen, and maybe our default is 2, but we wanted to control how big that shape could be. We didn't want another class coming in saying make that shape 10,000 by 10,000, because that doesn't really make any sense. I mean, if you have a 4K monitor, you're like 3840 by whatever, it won't even fit on the screen. So we don't want to do that. But if we make these protected like this, now each class that inherits from shape can control the height or do whatever they want with the height. So for instance, like we go over here to circle, and I want to come in here and say height is equal to 20. Right? That's no big deal. So let me put a breakpoint here. And you will say with shape, height's 2, width's 2. And now they got a little star here. That means they're protected. They're not locked anymore. They're protected. We step in the draw, height is 2, now height is 20. And we come back out, and you're going to see shape, height is 20, width is 2. So you have full control of those. And that's how the protected works. So anything inherited from this, you can use it, just like I talked about in the last video. You can also do this with methods. So you could add in here protected. So any member can use any of these access modifiers. And you could put protect in here. However, if we do that, then program over here, see how, well, you're just like, wait a second, we still have access to draw, right? So let's run that. And it's the circle draw cannot change access modifier. So it's not even going to compile. So we can't change this from protected to public, okay? So this is going to be protected. You can't change this an access modifier at all. You got to, when you override, it's got to stay with it. So that would be protected. But the problem is you won't be able to see it out here. Okay, so there's no real reason to do that. So we just keep that as public so we can keep using it. And we'll keep this here as public also. Now, the virtual, like I said, it allows you to override. Now that means that you could, if you wanted to, you could call the base. If there was something in the base that prepared stuff, you could still call base. And if you run this completely, you got performing drawing task and performing circle drawing tasks. So this was the base call. This is the call right here. I'll put a breakpoint here so you can see this happen. So the base draw brings it up to shape when you hit F11 or F10, F11. And then it will write performing drawing task, and then it will come right back where it was and continue on down the path. This method at this point has stopped. There's ways to allow this to keep moving down, and we'll get to that in a deep dive. So that's really it about overriding a class. That covers everything about the differences between methods in a class, except you can always make this static. And remember, we talked about this before, but once it's static, you can't virtualize it. All right. So if we put in something here that said static public void hello world, any kind of method in the world that you wanted, you could put in here hello world. So you could put in here hello world. Now this is internal, which is fine, and it's a static. It builds, so we can go up here to program, and from circle or shape or anything, you could just call hello world. I can do this from shape, hello world. What I can't do is I can't come down here to an instantiation of shape or circle or anything. You won't find hello world because it's at the object, it's at the class level. So if we run this and you look at shape, it's null. There's nothing there. Hello world has just produced. That there will throw another hello world. And then when we create shape and you look down in here, there still is no method or anything being shown. Because all you see is the properties. And if you look at the screen, you'll see hello world performing tasks. Static methods are not used a lot, but they are used, and they are some. Okay, so now that we have static methods, we have virtual methods, overriding methods, let's get into a little bit of the polymorphism from a dynamic point of view. Now, if you remember originally, we were talking about doing polymorphism with a constructor or any kind of method. Say if we had a method here, we're just going to call it draw, and I put in here an int x and an int y. This would be okay because, again, we talked about this in the last couple of videos. This parameter set is different than here. So that's static because when you call into this from here, the compiler knows which one you're calling. Dynamic is when the compiler doesn't know and the call can be changed at runtime. So the only way to do something like that is from an inherited class. So we have shape, we have circle, rid of this, which says performing circle drawing tasks. We have square, says drawing a square. Rectangle says drawing a rectangle, and triangle says drawing a triangle. So let's go back to circle here, and we'll just say drawing a circle, so it matches everybody else. And then we're going to put some colors around this circle here, and I'm going to make this a color like magenta. We'll go with magenta. And then on the other side, this is going to be white, because we have to set it back to the same color. One good thing to do is experiment with console and like all the different types of attributes and settings that you can use here. There's a lot of different things that you can do with the consoles. So that'll build. Now, when I was talking about things that are going to be dynamic, they're only dynamic as if you do something like this and you say you're going to make this a shape, but you're going to instantiate one of its children. You can't go the other way. You can't say circle and instantiate a shape. You can only name the parent over here, shape, and instantiate a child. And there's good reason for that. And that reason is, what you're about to see here is because of the dynamic polymorphism, where you can take a circle and put it in as a shape or a rectangle or a triangle, because they're all shapes. And if you were taking this in as the parameter, that's what you'd want to do. You'd want to be able to take the circle and put it to a shape. So we do something like this, and I run it. You're going to say drawing a circle, and see how that came out in magenta. That's because it was called from here. Okay? We never made it up to here because this was virtual, and we said we're stopping at circle. And that was, and I know you're going to think right now that, well, that was known by the compiler, and I 100% agree with you. Let's talk about how this can actually be dynamic and that the compiler doesn't know what's going to be set. And the way that we do this is we switch this to say shape is equal to null. And then we have to add in a switch case. And I'm just going to drop this in and we'll walk down it. So the switch happens and there's a little system class called random that we can instantiate. Let's run this instead of for 50 times. Let's run this for 5. And so we have 4 different shapes. We have a circle, rectangle, triangle, and square. And the random will return something between 0 and 3 because we're telling it we want 4 options. Remember, C# is a zero-based language. Once one of these has been hit, that shape will get randomly created. So it'll be a circle or a rectangle, a triangle, or a square, but we have no idea which one it will be until runtime. Once we have that, we can say shape.draw, and we can put a little question mark there that says, if shape is not null, then call draw. So let's see how this works. Hit F5 and random F10. This is our first time in. The first value is a 2, so we're going to create a triangle. Now again, this is happening at runtime. There's no way that the compiler would know this was happening. So we step into draw, and that is for the triangle. You're going to get red, drawing a triangle, white. The next time through, I is equal to 1. The random number is 0, and that's for a circle. And we ended up with a circle here. We want to call draw. I'm just going to let the rest of them run through, and we can look. So we had a triangle, 2 circles, and then 2 more triangles. So that is a pretty good example of how dynamic polymorphism works. Now, if you wanted to see how random this really is, we could drop a dictionary in. You could put them in like this, and that's creating a dictionary. And this is part of the collections that's coming up here in a couple videos. So this is a dictionary, and it takes in, this is a generic, okay? So it's a collection, it's a generic, it's kind of a mix, but you can put anything in here you want. You could put int and int, you could put string and string. I could put a shape in here. This is just any type of data type. Now these are giving me squiggly marks because shape is not a string. So you create counts, and then you add counts, add circle to 0, add rectangle to 0, add triangle to 0, and add square to 0. And then what we would do is down here is you would say counts for a circle. You're going to increment that. And you would do that for triangle, rectangle, and square. So you drop rectangle, triangle, and square, and these would get incremented. And then at the very bottom, you would just print them out. And so after the for loop, we would print these out. So the way that you would do that, you put the dictionary and the key in, and that will find the value. So let's let this run. And I'm just going to let it go down. But so at this point, you can see counts has all of the keys that we have, and these are called key value pairs. There's a key and a value. That's what they're called, key value pairs. And they're all set to 0. As we go down through this, then counts for triangle here should be at 1 because we've incremented it. And then you go down at the very bottom and you print these out, and then they will all be set. So you're just going to call out whatever the value is. For instance, circle will get 9, rectangle will get 16, 13, and 12. So as you can see, there's a variety that got called: triangle, rectangle, circle, square. And there's your circle 9, rectangle 16, triangle 13, and square is 12. This is just proof that this is totally 100% random. It's dynamic. The compiler has no idea what's going on, so that's why it's called dynamic polymorphism. This is extremely common in applications. If you ever use Visio or any kind of drawing application where you go over and you grab a shape and drag it onto a sketch and drop it, if you were to grab a circle, then this would be called. If you grab a rectangle, this would be called. If you grab the triangle, and yada, yada, yada. So that's dynamic polymorphism. Thanks for watching the video. Like and subscribe to the channel. I really hope you enjoyed this video and are understanding how object-oriented principles work. The next video I will go over abstraction and interfaces. That one's a ride. You're always welcome here at C# Workshop, and as always, have a nice day.